Welcome to lesson 43, part 1. We're doing monomials today. A monomial is just simply a number, a variable, or a product of a number and variables. Examples look like that. 5x, see how that is a product of a number and a variable. Okay, a number and variables would look like this. So that's non-x squared y to the third, or y cubed, however you want to say that. And also a monomial could look like this. It's negative 6 over 11. So all of these are examples. Here's another example. And lastly, we could have 2xyz squared. Still a monomial. Monomials with the same variables and exponents are like terms. So you should be pretty good with like terms by now. All that means is, let me switch over to this real quick. All like terms means is 2 plus x, or 3x plus x plus 1, or 2 plus x plus 7. So these are all different problems here. This one is already simplified because this does not have an x and this does have an x. So 2 plus x is as final as we can get that. 3x plus x plus 1, these are like terms because they both have an x, so that would literally look like, so 3x plus x plus 1 would be, you can just count these, you'd have 4x plus 1, so those are like terms, that's what we end up with. And then 2 plus x, again, we can't do that, plus 7, well 2 plus 7 we can do, so you could rewrite this like that. It'd be 9 plus x. Okay, so some review on like terms there. To add or subtract monomials, you are going to combine like terms. Do not change the variables and exponents. Underline that a billion times. Do not change the variables and exponents. We'll talk about that here in a minute. So whenever we add or subtract, it just simply says to combine our like terms, so that's what we're going to do. 17x minus 25x, they both have an x, so this is essentially the same thing as 17 minus 25, which would be negative 8, but again, they both have an x, so it's negative 8x. Number 2, these are both y squared, so we can definitely do this operation. Negative 23 plus 6 would give us negative 17, but with y squared, so negative 17 y squared. Go ahead and try number 3. See if you can come up with that one. All right, hopefully you knew that this is a cubed, this is a cubed, and this is BC, so these are like terms. This is an a cubed BC, as we would call it. Negative 15 plus 6 would be negative 9, so that'd be negative 9 a cubed BC. We have negative 9 a cubed BCs. Very simple. Number 4 you can do. Number 5 you can do. Actually, let's talk about number 5. So like terms, meaning, let's go back to the 2 plus x example. What if this was xy plus yz? Well, again, this is as simple as we can get it because these are not like terms. This is an x and a y, and that's a y and a z, so no, can't do anything else. All right, this is an a and a b and an a and a c, so there's the answer. All right, so you got to be careful of that. If they're not the same variables and they're not raised to the same exponent, it's not like terms. But if they are the same variables with a coefficient and raised to the same power, like that one, and this has an exponent of 1, they're the same, then you can combine them, okay? You can do the operation then. All right, otherwise you cannot. We leave it how it is. Okay, let me do number 20, or sorry, not number 25. Let me do number 8. So first what you need to do, if you've not figured it out yet, we need to go ahead and see if these variables match up. And then their exponents match up as well, so that's good. Both of them do. These are like terms. So it'd be like negative 25 minus 25. Would that be 0? No. It would be keep, change, change. In other words, keep this, change that. And that would be negative 50 x to the 4th y cubed. All right. So you guys can handle that. It's not too bad. Go ahead and finish the rest of those. Here we're going to be multiplying monomials. To multiply monomials, you use the product rule. Product rule I have right here, x raised to the a times x raised to b equals x. You just add the exponents here, a plus b. So whenever you see this, you just add these two things. And that gives you, let's say this was x cubed times x cubed. That would just be x to the 4th. All right, you don't have to copy that example because I can see we have one perfect, almost exactly alike right here. So x squared times x cubed. Sometimes people might think that it would be, that the answer to this might be this, or just, anything else. I don't know what people would come up with, maybe this or something. So it's definitely not that. All you have to do is add 2 plus 3. That gives you an exponent of 5, and it's just x raised to the 5th. So it's that easy. All right, so you try 18. Hopefully that wasn't too bad. A is raised, even though there's not an exponent there, it's an assumed 1. We always assume 1, It's just how we are. 9 plus 1 gives you an exponent of 10, and it's still a to the raised to that exponent, so a to the 10th power. Number 19, go ahead and try. If you can get that one, you're doing good. You should have just added 7 and 4, that's 11. And our variable that we're talking about is w. So w raised to the 11th power. Examples with coefficients. All right, so let's say, here's our example, 2x squared times 3x cubed. All right, so all you have to do here, and these are in parentheses, all you have to do is kind of multiply each thing you see. So here we didn't have to do anything with the 1, or the assumed 1, because 1 times 1 is 1. That gives us a coefficient of 1. We don't have to write it or do anything with it. Here we do. So 2 times 3, we know that. That's just 2. We know 2 times 3, that's definitely going to be 6. All right, and then we have to follow the power rule. We can't get carried away with the multiplying stuff. We can't say it's 6x to the 6th, because that's 2 times 3, remember? We have to add our exponents, right? So 2 plus 3 be to the 5th, 6x to the 5th. All right, not too bad. So number 20, we would multiply 4 and 3 first. So that gives you 12. And then our variables, x squared times x to the 5th would really be 2 plus 5. That gives us an exponent of 7 for x. So 12x to the 7th. Number 21, again, 3 times 5, 15. X is there. This one has 6. This one has 2 as an exponent. So 6 plus 2 is 8. Boom. Not too bad. Go ahead and try number 22 and try 24. 22, you should have got 30x to the 6th. That one's easy. This one, that would be negative 7 times negative 4, which would be positive 28. P to the 9th times p to the 2nd. All we have to do to multiply a variable with an exponent times a variable to an exponent is add the exponents. So that's p to the 11th. And then we got q to the 3rd and q to the 6th, so that's going to be q to the 9th. And then we got r to the 1st and r to the 4th, so that's r to the 5th. Hopefully you got that. If you did, it's okay. That's how you do it though. Let's look at one down here, and then I'm going to stop. This one is kind of a culmination of what we did on the front side with what we're doing now. So at first we need to do this, multiply these. 2 times 4 is 8. X to the 5th times x to the 1st would be x to the 6th. Y squared times y cubed would be y to the 5th. Just adding those exponents. Plus, just carrying that plus sign down. So x to the 4th. And okay, so here's a little trick. There's a 1 right there. Again, 3 times 1 is 3. X to the 4th times x squared would be x to the 6th. Y 4th times y would be y to the 5th. All right, and can we do anything else with that? We absolutely can. This is an x raised to the 6th and a y raised to the 5th. Same thing. So this would be 8 plus 3, 11, x 6th, y 5th. Boom. Go ahead and finish that out. You got it.